All right, guys, so first little thing of break. And by now, y'all should have probably watched the video that I posted for YouTube that had going over like the steps of going over how to do every type of like reaction in a video. And it was breaking down all the different types of problems, but they were pretty simple types of problems. And I don't think any of them were on your homework. So what I've done is I've actually gone through and I am going to show you how to work out some of the ones that you might have had trouble with. I've got one of each type of problem that you are going to do in your homework tonight written out, and I'm going to go through these with you. And also one other thing I've got written up here is I've got some steps for you written down that should help you. So step one says when you're trying to predict the product of a reaction, the first thing you should always do is think about reaction types. So you should think about it. What is this, a single replacement? Is this a synthesis? And then write it down. The next step, that you're going to do for these types of problems is you're going to note the charges of each atom or polyatomic. Meaning that, like, if I come down here, I'll show you. So if I'm looking at this right here, PBr3, this is a covalent bond because phosphorus and bromine are both nonmetals. We have this 3 right here. So we know that the charge on phosphorus is going to be 3. So we're going to make a note of that. We're going to remember that. And so the next thing you're going to do is make the necessary charge switches for ionic compounds, meaning that you're going to cross them up right here, like it's done in the problem for you. That's the first step. And then the next thing you're going to do is swap the elements / break down compounds. And break down compounds, that's more for decomposition, but you remember how we did the A plus B yields AB? So that's what you're going to do next. You're going to look at your sheet that you took notes on during class for that, and you're going to make those swaps with the elements. And the last thing you're going to do is very important. You have to make sure to balance all of these problems. And another thing I've got written up here is I've got the Brinkelhoffs, just so I remember what all needs a 2 if it ends up by itself on the product side of the reaction. So let's go ahead and go through this. I've got the question that it is on your homework written down underneath it. So this is number 3 on page 12 if you need to go ahead and go through and pause this to go ahead and find, because I'm going to be switching back and forth as you can see. But this one is page 12, number 3, and we've got O2 plus H2. So what type of reaction do we think this is going to be? That's the first thing we're going to think about. So if I'm looking at this, Torres, what do you think this is? Okay, synthesis. Good, right, exactly. I knew you'd get it. All right, so I'm going to come up and I'm going to write synthesis right here. So we know that this is a synthesis reaction, and we know that that means A right here plus B is going to yield AB. So do we know something that has H and O? I think we might. So what I'm going to do is I'm going to come over and I'm going to write my product, which in this case is going to be H2O. So that is AB. That's A plus B. It's in a different order, but this is going to be water. So the next thing we're going to do, we've already swapped the charges and we've broken the compounds. Now the last step, balance. So are we balanced? Ashton, are we balanced? No, we're not. So we've got 2 H's and 1 O on the product side, but we've got 2 of each on this side. So what I'm going to do is I'm going to write a 2 right here. Let's see, now I've got 4 hydrogens and 2 oxygens though. So the last thing I'm going to do is I'm going to put a 2 right there. So that's that problem. We're balanced, we know the type of reaction, and we've got non-product. So easy enough, right? All right, let's move on to the next one. So the next one says PBr3, and this is page 11, number 6. In case you need to pause it and go ahead and switch to the other page in your homework. So, what type of reaction is this? Isabel, what type of reaction do you think this is? Good. Decomposition, exactly. Great job. I knew you were listening. Okay, so what I'm going to do over here, I've got A and B, so a decomposition reaction yields A plus B. So I'm going to write P plus BR. But Mahia, what am I missing on one of these two? Exactly. If we come over here, we'll remember that this is the B in Brinkelhoff, the BR in Brinkelhoff. So this BR needs a 2, doesn't it? Needs a 2 by itself. This is one of our diatomics, one of our Brinkelhoffs. So we're going to put that right there. But are we balanced now? No, I don't think so. Because I've got 2 BRs and 3 right here. So what I'm going to do, 2 and 3 though, that's a bit of a tough number, isn't it? So what I'm actually going to do is I'm going to come over here and I'm going to, let's see. We're going to balance P and then BR. P, BR. BR. So we've got one of those, 3 of these. One of those and 2 of these. So what's a common denominator for these two? It's 6, right? That's the least common denominator between the 2 of these. So what I'm going to do, I'm going to write a 3 right here and then a 2 by my P. So now I've got 2 P's and 6 BRs. And I've got 6 BRs over here, but I've just got the 1 P still. So last step, I'm going to write a 2 right here. So finally, what do we end up with? Are we balanced? Are we balanced now? Yes, we are. We've got that. Oh, also, I forgot to write decomp. I'm just going to write decomp right there. I'm going to shorthand it. So we're balanced. We predicted the product. And now we have our balanced equation. So yeah, I'd say we're good on that one. All right, let's move on. Okay, so this one. Who do I want to ask this time? I don't know. Okay, so what type of reaction is this right here? That's our first step. Think about reaction types. What type of reaction is this? This is a combustion reaction, isn't it? Because we've got the CXHY, in this case C2H4 plus O2. So we automatically know right now that this is a combustion reaction, which also tells us what, by the way, this is page 11, number 3. This also is going to tell us what our products are. We know that every time we have a combustion reaction, our product is going to be the same, and in this case, it's going to be CO2 plus H2O. That is always what the product of a combustion reaction is going to be. Let me see. I'm going to squeeze combustion right here. Okay, so this is a combustion reaction, page 11, number 3. So what do we need to do now? We've gotten our product, so now we need to balance. That's our last step. So are we balanced? Let's see. I've got 2 carbons right here, 1 right here. So automatically I'm already seeing that no, we are not in fact balanced. So what I'm going to do first is I'm going to put a 2 right here in front of this carbon. So now we have 2 carbons, 2 carbons. How many hydrogens do we have? 4 hydrogens. Ooh, 2 hydrogens. Ooh, I don't like that. So let's go ahead and put a 2 there. But I'm going to go ahead and write this out. CHO, this is the order that we're supposed to balance in. And over here, I've got C2H4O4. And I'm going to go over to my product side now. I've got 2 carbons, 4 hydrogens, and how many oxygens? Ooh, I've got 6, don't I? Let's see. 2, so that's 4, and then 6. So what do I need to do now? The last thing I'm going to do, since I have, lucky for me, I've got this oxygen by itself, don't I? So what we can do, since we need 2 more, I'm just going to put a 2 right there. So now I have 6 oxygens. So Kenna, are we balanced now? Yes, we are. We're balanced. We've got 2 carbons, 4 hydrogens, and 6 oxygens. So we're all balanced up. So check mark right there. No Brinkelhoffs. We've got our product. So let's move on to the next one. Also, still, if you need to pause and slow down or rewind at any point, go ahead and do that. This video is just here for you. I made this to try to get some harder ones than the video showed you, and hopefully this helps you. So the next one, page 11, number 7. So we've got HBr plus Fe. So what type of reaction is this going to be? Read. What type of reaction is this going to be? HBr plus Fe. Single replacement. Right, you knew it. I had faith in you the whole time. Single. So I'm going to just keep it with single right there, sticking with the shorthand tonight. So single replacement, if you remember from your notes, is AB plus C yields AC plus B. So we've got A, B, and C right here. So I'm going to make my switches on the product side. So I'm going to write, let me see, why's my brain not working? No, it's AB plus C yields BC plus A. Actually, misspoke there. So you have that in your notes, so just don't listen to me. FeBr plus H. What am I forgetting? Ooh, I forgot something, didn't I? Dante, what did I forget? Ooh, you're right. This is a Brinkelhoff, right? Okay, so yeah, so this H needs a 2. Right, so now, also, this is another reason I wanted to do this problem. This problem actually does not tell you what the charge is on the iron. And iron is a transition metal. That's just something that happened with the worksheet. So I'm going to go ahead and tell you, write this down on your sheet on page 11, problem number 7. On the Fe, come up here and write plus 2. Because I realized that when I was going through these problems, I realized that iron did not have a charge on it, did not have a defined charge in the beginning of the problem on the reactant side. So that's why I wanted to do this one for y'all. So go ahead on your sheet, on your actual worksheet, write a plus 2 right there. So now that we know this charge, what's the charge on bromine? You're right. So bromine has a charge of -1, and Fe has a charge of plus 2, like we just said. So we're going to switch these, aren't we? World's tiniest arrow. Okay, so this Br needs a 2 right here because of the charge on iron. You know, remember your crisscross as what did America call it? Doopy or whatever, doofy, I don't know, something like that. So the last thing we're going to do now that we've gotten our product is we're going to balance. It's our last step. So are we balanced? No. So H1 Br1 Fe1. Now over here, Fe1 Br, I'm doing this in the wrong order, aren't I? Yep. Yeah, I didn't write these in the same order. Just bear with me. Okay, so Br, you write it in the correct order. Br2 and H2. Okay, so we need to fix those. So diagonally this way, I'm going to say, okay, my irons are balanced, my metals are all balanced. What about my nonmetals? 1 and 2. So no, these are not balanced. So I need to put a 2 over here, don't I? So I'm going to come up here and I'm going to put my 2 in this blank. And so now I have 2 H's and 2 Br's over here. But now look. Whoa, cuckoo bananas, yo. We're balanced. We've got two H's, two H's, two Brs, two Brs, one iron, and one iron. So we're done on this problem. HBr, 2 HBr plus Fe yields FeBr2 plus H2. We're all balanced. So that's our single replacement reaction. So the last and final one that I wanted to go over with y'all is page 11, number 8. And so for this one, we're starting out. What type of reaction is this? Shadow, what type of reaction do you think this is? Exactly, double replacement. Knew it. Knew you had it. So, double. I'm just going to stick with double. Give it the underline right there. Okay, so double replacement, AB plus BC yields what? Yields AD plus CB. Okay, so this is A, this is B, this is C, this is D. So I need A and D to be together, don't I? So I'm going to come over here and I'm going to write KCl. Now, what are the charges on K and Cl? The charge on potassium, what is that? It's all the way on the left. So this is a +1 charge and Cl is a halogen, so it has a -1 charge. So this is 1 to 1, so we don't need any subscripts right here. Plus, what are my last two? I have zinc and permanganate. So we can see right here also that we remember what's the charge on Cl? -1, exactly. So what does that mean for this 2 right here? Why is this guy hanging around right here? So the reason for that is because zinc, it has a defined charge, doesn't it? We know this. We know from our periodic table, you remember the 1, 2, 3 from silver, zinc to aluminum. That little diagonal line right there goes 1, 2, 3. 1 silver, 2 zinc, 3 aluminum. So we know that zinc has a 2 charge. So, and from looking at this one, we know that permanganate also must have a -1 charge since it also didn't give potassium a number right here. So manganate has a -1 charge, so I'm going to go ahead and write ZnMnO4, and then we remember that zinc has a +2 charge, so I'm going to get my 2 right here. All right, so big question now for this big problem. Are we balanced? James, are we balanced? Nope, we're not. So I'm going to come through. I'm going to start out with my metals. K, then Cl. No, zinc is my other metal. Zn, Cl, and MnO4. Since this is a polyatomic, this is permanganate, this is going to stay together, we can count it as one little item so that we don't have to write out a bunch of different stuff for manganese and oxygen. I think that's just a little neater. K, Zn, Cl, and MnO4. All right, so let's see, let's go ahead and get a count. There's one potassium, one zinc, 2 chlorines, and 1 permanganate. And over here, there's 1 potassium, 1 zinc, 1 chlorine, and 2 permanganate. So going down the list, potassiums are balanced, zincs are balanced, chlorines are not. There's 2 over here and there's 1 over here. So what I'm going to do is I'm going to put a 2 right here in this guy. So now I am left with 2 potassiums. Ooh, I've knocked out my potassiums. So, ooh, what does that mean? So that means I'm going to come back over here to this side and I'm going to give potassium a 2 over here so that everyone's happy. Law of conservation of matter. Nothing can be created or destroyed. So that's why we have that. That's why we make this 2 over here also. So there's 2 of those, but I've also added another permanganate. Oh my gosh, yay. We balanced everything. I'm so happy. We're balanced and we've created the product. All right, so that's the end of that. That's our double replacement reaction, and that is a balanced double displacement reaction with the product predicted even. So I hope this helped you guys. I just wanted to go through a few of these. I know this took a long time, the video is at 20 minutes. So I know this took a while, but I wanted to get this myself to help you guys. And I just wanted to go through some actual problems on your homework. So I hope this helped. If you needed to pause at any point in the video, feel free to go ahead and do that. And your homework for tonight is pages 11 and 12 in your packet, which if you follow along with this video and the video that we gave you in the YouTube link that we gave you to watch, then you should be fine. It shouldn't be a problem at all. And also, just a couple notes that I wanted to make. These are problems that I want you to omit because they are ones that we're not going to be doing. So page 11, number 4 and 6, go ahead and just mark those out. Go ahead and draw an X over the 4 and the 6 on page 11. Those are ones that you're not going to have to do. And so, yeah, I hope everyone enjoys your quote-unquote break. And be sure to stay up to date on this because it is important for the rest of the semester. And yeah, hope you all have a great rest of your day. Be sure to get this in.